This is a pre-built version of the application. So if we go ahead and start the server and two clients, and this will be the server, and this is the first client, and this is the second one, and P here is prime, and alpha is a cyclic group generator. So both Alice and Bob agree to share those two values for P and alpha, and for the purpose of this tutorial I had the first user that logs in enter the values. So in the previous Diffie-Hellman tutorial I had a typo here, so this is the correct display here and here. So here we will be doing a deterministic encryption scheme, and what that means is let's say, so we send this message from Alice to Bob, and if we send it again, we will be sending the same ciphertext. So a deterministic encryption scheme is a cryptosystem which always produces the same ciphertext for a given plaintext and key, even over separate executions of the encryption algorithm. And examples of deterministic encryption algorithms include RSA without encryption padding. And deterministic encryption can leak information to an eavesdropper who may recognize known ciphertexts. So this tutorial is a precursor to El-Gamal algorithm tutorial, which also uses or is based on Diffie-Hellman and uses multiplicative masking, but it is a probabilistic encryption scheme. So we would not see the same ciphertext for the same message in the case of. I will start by creating a new project, and this will be heavily refactored from the previous Diffie-Hellman key exchange project. So we will have two packages, a server one and a client one. And same as before, in the server package we will have two classes, a server class with a main method and a server thread class which will extend from thread And on the client side, we will have three classes: a client class with a main method, and a client thread class, and this will extend the thread class, and a Diffie-Hellman key exchange helper class, which will contain all the Diffie-Hellman key exchange logic and the multiplicative message encryption and decryption logic. And to do JSON, we will use this package as in the previous Diffie-Hellman tutorial. So we go to properties and Java build path, and the server thread will have a server and a buffered reader and a print writer instance variables, and those will be initialized in the constructor. Which will take in a socket and the server instance. So we will use the socket to initialize the buffered reader, and we will use it also to initialize the print writer. And the server will have a port number that it will be listening on, and a set of server threads with different clients that it is interacting. And here in main we start the server and the server socket given its port number, and we indicate that passive Eve is watching all communications, and we accept connections from the various clients, and we'll have a server thread dedicated to it, and we put all the server threads in this set, and we start that thread. And when we do that, the run method will end up being executed when the operating system decides to do so. So if we go back here, we will have those two methods. So this is just a get method, and this method forward messages from Alice to Bob and the other way around. And let's add this forward message method, and we will have this code in the run method, which will handle incoming JSON messages, and will open up those messages and display their contents before forwarding it to the other client. So here we are doing the forwarding. So this should do it on the server side, and uh, next we will do the client side. Now this class will keep track of the client and P and alpha and the private and the public keys and the common key, and the client is initialized in the constructor, and we will have those get and set methods. And the client class will have those three instance variables, and get and set methods for them, and those two static methods. This one turns character to ASCII, and this one turns ASCII to character. And the client thread will have those three instance variables, and we will initialize them in the constructor. Which also takes in a socket. Now the client will have two methods. This one will handle everything until obtaining a common key. And this one will handle communication using a common key multiplicative mask. And in main we will start by instantiating a client, and a Diffie-Hellman key exchange helper instance passing in the client. And for the purpose of this tutorial, the server will be on localhost, listening on this port number. So we instantiate a socket, and we instantiate and start a client thread, which will end up triggering a call to the run method when the operating system decides to do so on the client thread. So here we are passing the socket and the client and the Diffie-Hellman key exchange helper instances. And we use the socket to initialize this print writer instance variable. And if we are ready to communicate and we have obtained a common key, then we go ahead and call the handle communicate method. And both those methods, the pre-communicate and the communicate, they take in a Diffie-Hellman key exchange helper instance variable. And this method will initialize the domain parameters So here we prompt the user for the prime number P and the generator alpha and their name, and we pick those up. And for the purpose of this tutorial, I had the first client that logs in enter the value for P and alpha, the agreed on value for those. So we put those values, the name and P and alpha, in a JSON object, and we send it to the other client. And this method calculates public key. So we prompt the user for a secret key, and we use it to calculate the public key. And we put it in a JSON object and send it to the other client. And this method calculates the common key and returns that key. And those two methods do the encryption and decryption using that common key. So here we are using that common key to multiply the passed in message in order to encrypt it. And return everything as a string. So we put everything in this string buffer and return it as a string. And to decrypt, we're using the inverse of the common key in mode P. So we are multiplying by that and returning the decrypted message. Now going to the client thread class, this method handles incoming messages. So we pick up the message and we decrypt it using the common key and display some information and turn it back into character from ASCII and display what happened. And this is the code for the run method. So here we are picking up P and alpha from the other client, and here we are picking up the public key, and here we are prompting the user to press enter in order to generate the common key. Otherwise, if this is a message, then we are handling it here. And this method handles all the pre-communications. For this client. So here we are initializing the domain parameters, and here we are calculating the public key, and here the common key, and we return a ready to communicate flag. And this method handles all communications. So here we are telling the user that we are ready to send and receive messages. So here we turn the character message into ASCII, and here we encrypt it, and we display some information, and we send that message to the other client in a JSON object. And finally, let's go ahead and test run the application. So this will be the server, and this is the first client, and this is the second one. So let's say Alice and Bob agree to use those two values for P and alpha. And Bob chooses his secret key, lowercase b, as being 5, and Alice chooses 3 for lowercase a. And Alice calculates her public key, uppercase A, and Bob does the same thing for his public key, uppercase B. And then they both generate their common keys, which end up being the same, 78 mod 467. And passive Eve can see everything except lowercase a, lowercase b, and the calculated common key. And in order to figure out what the common key is, she needs to find what lowercase b is or what lowercase a is. And in order to do either of those, she needs to solve a discrete logarithm problem, which is very hard for very large numbers. So Alice will encrypt with the common key, and Bob here would decrypt with the inverse of the common key and obtain the message that Alice sent. And if Bob wants to send a message to Alice, he would encrypt with the common key, and Alice would decrypt with the inverse of the common key.